Good afternoon, everyone, and welcome to Riverfest 2025. My name's Karen from Australian Environmental Education, and today we are going to explore where the river meets the sea. So if you did a trivia with us before, some of the things we have actually looked at already, but we're going to go through a whole lot of different ideas about why water is important, the impacts that we have on our waterways, and I've got some experiments that you can do at home as well that we'll be having a look at. So I'm just opening up the chat. So if you need to ask me a question, or if I'm asking you a question actually, please put that in the chat. And if you've got a question for me, you can either put it in the chat or the Q&A. We'll see how we go. If it gets really busy, then I will have it just as in the Q&A so I can track it for everyone. Okay. And I want to be able to put stuff to everyone as well. Excellent. So we're doing Riverfest in September. So there's a couple of reasons. So one, September is Biodiversity Month. There's also Threatened Species Day, World Rivers Day, and World Water Day. So we're looking at water because it's so significant and important. Every living thing needs water to survive, including us. So let's have a look at some of our slides. And yeah, please feel free to put your questions in as we go forward as well. So one of the key things, sorry, I've just lost myself. One of the key things about water is where it's accessible. So most of the water, 97% of the water on Earth, is actually found in the oceans. So it's salty. We can't get access to that. We can't drink straight salt water. So that's why you might have heard of something of desalination, which is removing the salt from that water. So only 3% of the water on Earth is actually fresh water. But of that, some of it is frozen in icebergs, ice caps, glaciers. Another percent of that is in groundwater. So it soaks into the ground, so we can't easily get it. So there's only 1% of easily accessible water. But even that, some's in lakes, some's in rivers, inside living things, water vapor in clouds, and also soil moisture as well. So only 1% of the Earth's water we consider to be easy and accessible. So it's not very much. And the water cycle is a really important part of us understanding about how water moves through the environment and how we get access to it. So water moves from, let's say, our lakes, rivers, oceans, and as the sun warms it, it evaporates. So it turns from liquid water into water vapor and moves up into the atmosphere, into clouds. And over time, gets heavy, drops back down. If it's in cold areas, it'll drop down as snow. Other areas will drop down as rain. So as those water molecules are joining together, they get heavy and drop back down. Water will travel to the lowest part. So eventually it will flow down through the soil, over the surface, into creeks, lakes, rivers. Sometimes the lake is that end point of that water. Sometimes they'll connect to rivers that will bring it to the oceans or the sea as well. But the water is constantly moving, and there's only the same amount of water molecules on Earth at any one time. So they're moving through these different states from being frozen, liquid, and in water vapor. And that's another really important property of water. And in Australia, or in all parts of the world, they're moving in what we call catchments. So catchment is literally something that you're catching the water in. So imagine it's that you cupping your hand, and if water falls on this side, it'll spill out the other way. But if it falls from your fingers inwards, it'll run into the bottom of your hands. So a catchment is those parts of the environment. So mountains and hills on one side, and the lowest point being your creeks, rivers, and other waterways. And if it flows on the top of one side of the mountain, it will flow into one catchment or into another. So in Australia, we're broken up into these catchments. The biggest one is the Murray-Darling Basin, which starts up in Queensland, flows through most of New South Wales and Victoria, and exits the Murray River down in South Australia. And within that big catchment, you can see there are smaller catchments as well. So maybe having a look at this image, you can put in the chat what water catchment you live in. Because it is important, depending on where you are, where the water will flow. And that's why they thought for a very long time that Australia had an inland sea, because the water was flowing away from the coast and they were wondering where it was going. So water goes on a huge journey through the centre of Australia. So I'm actually just north of Sydney. So I'm in one of the catchments in the Central Coast that flows directly out into the ocean. So where I am, the water flows actually away from the beach, because there's a big hill behind me, and it flows into Brisbane Waters, which is in the Central Coast. So that's where my catchment is flowing. The other really interesting thing about Australia and our water is where we're all living. So about 85% of the Australian population lives within 1 hour travel from the coast. So lots of people live far from the coast, but most people live on that coastal edge. So again, we need to be thinking about what we do in our environment. So another property of water, we've mentioned those different states: water vapor, ice, so solid, and liquid as in water. But one of the other things about water is linked to, I'm just going to see if my next slide has no, I don't have my H2O diagram here. But the H2O, the molecule of water, so hydrogen, there's 2 of those attached to a single oxygen, but they're quite sticky. They like to attract to each other. And again, this is an experiment that you could do on a plate and actually have drops of water. You could make those different colors. And if you wiggle the plate around, eventually those water droplets will attract to each other and they will attach. If you've ever filled a glass of water up really full and had a look at the line, you may see that it's slightly raised, because water has something that we call surface tension. And it's one of the reasons that we can have our insects here, or spiders, or animals that are really light, looks like they're walking on water. So we can see the legs here, just makes a little indent, but because they're spreading their weight out, they can actually walk across the water without sinking. You can try this with a needle or a paper clip, or you could make a little aluminium foil insect and you can float it on the top of the water. I'll send some of these experiment ideas to you as well. Because of the property of water that it sticks together, they're attracted to each other, which is really, really important. And some things mix really, really well with water, but there are other things that don't mix well with water either. So I'm going to show you a couple of experiments now about water. I'm just going to stop sharing here for a moment to have a look over on my containers that I've brought with me today. So there's a couple of things that we're going to do. One of them is something that we call capillary action, and that is water moving up. So we think about water, if we pour it somewhere, it flows downhill, but we do have times when water will actually move up. So I'm just going to tear a little piece of paper towel, because this is the easiest way to see it. We're going to use this water for something else a little bit later as well. So I'm just rolling it into a bit of a tube. So this is just normal paper towel that I would clean my kitchen with. I'm going to twist mine. I'm just going to pop it in a container here that you can't see just yet. And now we'll have a look. So I've put my paper towel in, but already the yellow is come up to here. So the water moves up. If I sink it even more, I'll take it out now. Try not to drip it everywhere. But you can see the water's moved all the way to here because it's moved up using capillary action into the paper towel. Now I'm going to leave that one there for a moment. So we're going to use that in a little bit as well. But I'm just going to move this one. I'll move it in front of me. There we go. Just going to move my technical things away so I don't get anything in my computer. So this is just plain water at the moment. And I've got some cinnamon that I'm going to put in. So some things don't like water at all. And we call them hydrophobic. And this can actually happen to our soil over time as well. If you've ever noticed after it's been really hot for a really long time, sometimes when it rains, the water won't flow into that soil very well. So I'm just sprinkling my cinnamon on top. Making a little bit of a mess. At least cinnamon does smell nice. So what I'm going to show is how it doesn't want to mix. So if I put my finger in the cinnamon, you can see my finger go all the way through, but the cinnamon is stuck to my finger and hasn't gone through the water. I've got a little stick here I can do it with as well. So even if I stir it, it hasn't gone through. So this is what we call hydrophobic. This is a great experiment that you can do as well. There's quite a few different materials. Cinnamon I like to do it with because it smells really nice, whereas some of the other ones don't smell as good. So one of the ways that I can break this is if I put detergent in. So if I put the detergent in, if you look, you can see the detergent dropping through as it's sinking, and it's pulling bits of cinnamon down there with it. So if I start stirring this, I can actually mix it because the cinnamon has broken that surface tension and it stops the separation between the cinnamon and the water. And so if I put my finger in now, I'll do it with my stick, it'll be wet. So you can see that it's actually wet now. The water and cinnamon have reacted. Now, there's another one that this happens with as well. I wonder if you've heard about another thing that water doesn't mix with. If anyone's done my trivia earlier today, they might know that. If you want to put in the chat. I'm going to switch these over. Wonder what this might be. What do you think? thank you, energetic jellyfish. Oil. Absolutely. So oil is a classic one that we often will hear. Oil and water don't mix. And I've got some oil at the top, and at the bottom here, I've got water and blue food colouring. So if I give it a stir, you can see the ripples at the bottom. But it drops straight back down really quickly because it doesn't separate. So imagine that you're an animal and there's been an oil spill and you live in the water. You could be a fish, you could be a freshwater yabby, but you need to come up. If you come up through the oil, it'll cover you. It might block your gills, stop you being able to breathe. But if you're a bird and you need to dive down to catch the fish, you'll be impacted as well, and you'll get all of those on your feathers. So both land animals and aquatic animals, so marine or freshwater animals, will get affected by this. Now, again, there's something else that goes in. I'm going to add more of my detergent. So I've got a detergent layer there. You can start seeing those bubbles forming. If I give it a big stir, we'll see that it's not separated anymore. I can actually see my detergent just, can you see it sinking, that big blob? It's just sunk through the oil water layer. It's quite weird to watch on my side as well. It's bright green. So it's sunk to the bottom. If I stir that now, we'll see that same, it's impacting that barrier. So this is fabulous when you're trying to clean your dishes and separate those kinds of things. But in our waterways, these can have big impacts. So not only do we have detergents, but we have those oils in there as well. So we do need to be thinking about what we put into our environment. And we'll talk a little bit more about that later. I'm just going to move these out of the way so I don't knock them as we do the next part of our presentation. So please feel free to continue putting your questions in the chat as well. And we will have a look. Oh, we've got one here in the Q&A. Ah, yes, one of our other participants is saying oil, exactly. So oil and water, lots of things about the properties of water can be really positive. Lots of things dissolve in water, like salts and sugars. That's why it's being used quite a lot in lots of different things, but other things don't mix at all. Okay, let's have a look back to our slides. So there's lots of great fun experiments you can do with water. So oil has direct and what we call indirect. So direct impacts, I can feel the direct impacts now because I've actually got oil on a bit on my skin. We could see the direct impacts, how it sits on top of the water can affect both aquatic and land animals accessing food or air. And that with detergent, it mixes. And that means it's mixed into the environment, which is even harder to clean up. So some of it enters our environment through air pollution. About 11% is runoff from land sources. Think about next time, especially if there's not been a lot of rain. Car parks are a good place to see this. When it's rained after a while, you can often see this sort of rainbow on the ground, and that's where oil has dropped out of people's cars or on the road. And when that gets wet, it gets mixed and eventually ends up in our drains as well. So there's accidental oil spills, but there's also about 24% that enter through normal operations over time. So filling and unfilling vessels, natural oil seeps. So there is quite a lot that naturally seeps from these underwater oil reserves as well. And these are ways that they can get into our environment. You can often see this. This is like a petrol or an oil spill on a river, and it could be near a marina or an area where there are lots of boats. And again, it could have just been over time, lots of small spills that have joined together. But we can see that that would impact any aquatic animals moving through that environment. This is a photograph that I took in after a big rain event in an area near Parramatta River in Sydney. So this is a small creek running through a reserve that joins up to Parramatta River. Now, lots of runoff. This bridge was actually blocked and it was actually got closed not long after this because a big tree got stuck and all of this other material got trapped as well. So often we'll get not just natural materials, and too much of that material is still produces too much nutrients for the animal life. But I can see plastic bottles and rubbish in here as well. Now, I have to say one of the great things that we've been seeing is the reduction of plastic rubbish because of schemes like Return and Earn, where you can hand in your bottles and glass and cans for 10 cents. And that certainly has been a great improvement to some of these areas. So 80% of our litter in our waterways is made of plastic. Bottles, bags, food wrappers. And this is what it looks like from under the water. Again, there are some great projects like sea bins, which are actually collecting the floating rubbish and they get to remove it. I might share a video that I took a few months ago when a bunch of balloons had ended up in one of the sea bins from someone having a party at a park near the city, and they left their balloons, they blew away, they ended up in the water. So instead of them looking like jellyfish, they sunk and were trapped by the sea bin, which is really good. We also get lots of sediment runoff like this as well. Okay, we're just going to step back a bit. We've got Benedicta asking, how do we clean up oil spills? Well, let's have a look back at our oil spill. So a lot of the ways, if it's not mixed, is they will put up what's called floating pollution booms. And these are tubes that sort of sit on the surface that trap that oil. So what it means is when the water goes in and out, it pulls up against that boom, and then they can physically sort of scoop it and move it out. Luckily, the further out in the ocean that oil spills occur, actually the safer it can be, because over time with the sun and the movements of the ocean, it will actually break it down naturally. But it's when those oil spills hit land and they can damage the sand, the banks, and any of the animals that get caught in that get covered with oil. And each time they clean it off, it can come back in a tide or the next rain. So really, really challenging. But while it's floating, they can actually physically remove it. So they will scrape the soil, they will dig, they will scoop up the water and skim off the oil to try to remove that. But it is a very, very difficult and complex process. So the best way is to avoid it getting in there in the first place. So that's the key. We can avoid that oils and pollution entering our environment, the better it will be. So the next slide that I was showing you is actually sediment. So it's not oil, it is looking at runoff from land after it's been cleared. Now, this particular runoff was up at the Central Coast. This is really quite near where I am. And this was after the bushfires in 2019. So in the beginning of 2020, there was a lot of rain. And because all of that plant material had been cleared, so much dirt and sediment and charcoal ended up flowing into our rivers because there was no vegetation to protect the land. And this is what we saw in a lot of places. Really murky water with lots of sediment and soil and clay mixed up into it. A little bit like how our cinnamon looked at the end. Really, really murky. And that has impacts on our animal life as well. So one, a lot of the animals, a lot of the water plants as well can't get sunlight. So they're impacted as well. It reduces the amount of oxygen in the water. That sediment will settle out in the ocean as well and can kind of smother and blanket other organisms that are living there as well. So it has a really big impact. And often when this happens, it's also bringing maybe fertilizers and pollution and chemicals out into the water as well. This is certainly a big impact that's happening up in the Great Barrier Reef, where we're getting runoff from agriculture and things like that flowing into the waters near the reef, and then it's moving out over to the reef as well. So we can see that same thing happening here in our reef environment. So we get it smothers seagrasses where a lot of sort of marine animals will live, and the mangroves where what we call the nurseries of the sea. So these can have impacts as well. And again, there are lots of great ways that we can stop that happening. So those pollution booms that we were talking about with the oil can actually protect sediment and rubbish and pollution runoff as well. So here are some of our different runoffs. So sometimes there's just a big pipe with our stormwater running straight into our marine environments. So that connection between the rivers and the seas is a pipe, essentially. So it's running off from the rivers straight into the stormwater, straight into the ocean. So things come through the atmosphere, dropping down. Things come from humans, pollution. A lot of coastal areas are impacted and rivers by dog poo. Just owners not being bothered to pick up the animal poo when they're going for a walk. A lot of the drainage systems are really hard surfaces, so gutters and roads just become like water pipes when it is really wet and rainy. So this is a really great way to think about it. A landscape can be a green filter or a grey funnel. So a green filter provides lots of areas where water can slow down. It can soak into the ground, it can soak into the parks, grass, trees and plants can then use it to stay healthy by sucking it back up in their roots. So it actually stays in that water cycle. It stays in the environment being used. And the more we can slow our water down, the better it is, the less pollution that's picked up. Whereas our grey funnels, like a lot of our cities, are hard surfaces, gutters, roads, car parks, and it's a really quick way for that water to move directly into the stormwater, rivers, creeks, and oceans. This is a really great experiment that you can actually try to do as well. I'll send you some links to it. You can use sand pits and things like that, and you can actually put little bits of pipe and things. And another area that might have bits of sponges or little holes like making dams or some plants and sticks. And you can see what happens when you pour water through the different environments. You can time it, make changes, maybe design a perfect catchment looking at a green funnel versus a grey funnel. So the green filters slow the water down, allow it to soak into the environment, planting lots of gardens as well, even rooftop gardens and vertical gardens. And the whole idea is trying to trap a lot of this sediment so it's not moving from one area to the other. Mangroves and salt marshes are great habitats for that. It slows things down. Thinking about sort of these rainwater gardens as well is slowing the water down into the environment. So they're great fun things to look at and explore as well. So here are some of our pollution traps. This one here is a big bag that's collecting the heavy pollution, but the water's able to move through. Lots of councils are doing these. Even if you look at your local car park, often they've got those grates on them. Those grates are also trying to stop big bits of pollution and plant material entering the stormwater directly. And these are different ways that we want to keep the environments healthy for lots of our different plants and animals to create healthy ecosystems, both in our freshwater environments, our wetlands, and our coastal environments. Okay, I'm going to have a look at, see if that's my last slide. Yes, it is. At some of the other ways that we can look at our water and what we can do with it. So feel free to keep putting your questions in the chat. I want to go back over to my experiments here. So we can see that our, oh, I'm going to get a stick. Our cinnamon hasn't separated back out. It is completely mixed because we added the detergent. And we do get a lot of detergents in our environments as well. So it can mean that some things that wouldn't usually mix, that make it easy to clean, then become mixed. We can have a look at this one here. This is our oil and water. So we've just got our bubbles at the top. So the detergent and the oil are all up the top, and it's separated out a little bit. We can give it another stir and we'll be able to mix that completely back together, but it has enabled the hard line connection between our water and oil to disappear. But let's have a look at this one here. Now, I should have used a different color, but you'll understand why I used yellow soon. This is completely wet. I can actually drip it because it is got so much water in it. But I want to have a think about this as well. So capillary action is a great way that our water moves around. But what I've got as well, and you'll understand why it's yellow now, it is just food colouring. I've got some pieces of toilet paper that I've scrunched up. So just squares of toilet paper. I'm scrunching up and putting in our water. When we think about what we put down our drains, we've got to think about food, oils, but also what goes down our toilets. So these ones here, I give it a big stir now. I'm just going to move my paper towel out. It's actually trapped around my stick. But what's important is that is still pretty strong. I can break it only because I had a thin piece because it's thick. So even paper towel and tissues, we shouldn't put down the water. So I've had this in for about 60 seconds. And while I'm stirring that, you can actually see it breaking down really quickly. So within minutes or moments of it being flushed, toilet paper will start breaking down. So it makes it much easier to travel through our sewerage system and then get cleaned before the water is treated at our water treatment plants. So you can see all of that. There's only tiny pieces now. If I put that big piece of paper towel in, we'll do it for the same amount of time because I've got a big piece still. I'm going to tear it up to the size of a piece of toilet paper, even a bit smaller. There we go. There's my piece of paper towel. I'm going to leave that there just to settle for a moment. And have a think about our urban water system. So we've got our natural water cycle, but we've also got an urban water cycle. And that's the layer that brings us water in our pipes to us to turn on a tap. It also takes away our wastewater. So we've got two types. We've got our what's called grey water, which would be things from a dishwasher a washing machine, they actually can be reused. So in the droughts of 2018, 2019, I had a hose from my dishwasher and my washing machine, and I would actually have that going out onto my garden. So I could use that grey water in my garden. I also had a pump in my bath, and I would suck out the shower water as well and use that in my garden as well during that really heavy drought period. Things like sewage that goes things from our toilet is called black water, and that goes to the sewage treatment plants where that gets treated there, and it doesn't get used as what we call environmental water. There are lots of places that are now recycling grey water, and it gets used for parks, for irrigation and those kinds of things. So it's not drinking water, but it can be used to water gardens and those kinds of things. So it can be really great way to protect those environments. Now, let's go back and have a look at our toilet water. Remembering that it is only food colouring. So here's my piece of paper towel again. If I stir it the same way that I stirred the toilet paper, which you can still see moving around, it's still coming out whole as one piece. So even after twice the amount of time that we left the toilet paper in, the paper towel is designed to be strong. You don't want your paper towel breaking down as soon as it gets wet on the bench. You want it to stay pretty strong. So it's designed to hold together. Whereas tissues break down in between the two, but they're still meant to be strong because you're blowing your nose on them. So you don't want them to fall apart in your hand either. But what's coming out of our toilet paper is that it's really easy to break down. And that's why wet wipes, even if they're said that they're flushable, they don't break down in the system. So really important to think about only putting things that will break down or natural in the toilets as well, and be really careful about what's going down your sinks. Too much food things can all have an impact. So I've got time for questions. That was a lot of talking about what can go on between our rivers and our oceans and our marine environments. But that connection is so important. Everything that we do on land has an impact to our freshwater ecosystems and our marine ecosystems as well. That's really interconnected. And we can think about the animals that use all of those environments too. So please let me know if you've got any questions or would like to know more about these experiments. I've got quite a few different ones I will be sharing with you as well, that are lots of really fun experiments that you can look at, that explores those different properties of water. Let's have a look. Any more questions in the Q&A or the chat? Well, as always, I will be sending some information afterwards. And if you do have questions that you didn't think of at the time, you are welcome to email me those as well. So Ashley's wondering, can mud be broken down? So mud, yeah, it absolutely can. It can get broken down into sort of smaller and smaller sort of sediment particle sizes. So mud, if it's dry, like in clay, once it gets wet, it will actually start breaking down. It'll start getting squishy and messy, and the wetter and wetter and wetter it gets, it dissolves and dissolves and dissolves. But if you left that mud in a container in the sun, the water would evaporate back out and you'd end up with that hard clay and mud again. So you can actually use that quite easily as a bit of an experiment to watch that part of the water cycle. Karen is asking, are there similar solids to cinnamon that will work? Yes. So another one is turmeric. White pepper will work, but it tends to be a bit sneezier. So there are quite a few of the light spices that will do that. But yeah, I tend to like using cinnamon because it actually just smells really nice, and because I do use it quite a lot. Um, Excellent. So Ashley's asking, what about sticks and leaves? So no, the sticks and leaves tend to take a really long time, and they would break down in the soil by lots of insect and fungus action. So if they're floating in the water, they'll usually sit on the top, and those big grates will kind of block some of the leaves and sticks from getting into the water. Eventually, over time, they bang into each other. They will break down into smaller and smaller pieces. But they don't sort of dissolve in water or break down the same as mud or sugar and salt and those kinds of things do. Marion's asking why dog poo is so bad for the water. Well, there's a couple of reasons. So any animal poo is high in nutrients and things like that. So sometimes a lot of that getting into the environment can actually cause things like algal blooms. Too many nutrients in the environment mean that the natural balance of the animals and what they need and the plants isn't there. Dog poo on its own, if it was one single dog poo, what's the harm? But if you think about how many people don't pick up their dog poos, like even if it's just, one person accidentally didn't bring a bag 1 week, but there's hundreds of people that go to that dog park and they all forget once a week, then those dog poos end up being hundreds and thousands. And over a year, they can be, millions of dog poos ending up in our waterways. But there's also other animal poo as well, livestock poo from agriculture. So some of them, they can leave diseases in the water as well. So we can get things like people getting sick from having too much different poos and bacteria coming from animal poo in the water. Sometimes it'll just be that it floats as well. So it'll be floating around and an animal might think it's food, but it's not. So that's how it can cause impacts, nutrients, bacterias, and things like that. Ashley's also wondering, can plastic bags break down in water? Yeah, they can over time, but what they break down to is smaller pieces of plastic. So you may have heard the term microplastics, and microplastics are small pieces of plastic. So a plastic bag breaks down into smaller and smaller pieces. It could also be eaten by an animal, and then that can get stuck in their stomach as well. But yeah, as plastics bump into each other, they break down into smaller and smaller pieces, and forming microplastics that can get all the way through our food chain as well. Oils over time will break down, and it just really depends on where it is. So anywhere near the shore or riverbeds or beaches have a really huge impacts of those oil spills. So that's why it's a key thing not to put oils down your drain. So I've got a jar by my sink. And I think about the different types of oils I have. Sometimes I can reuse oil and reuse it in cooking. So if I've made something that's really nice, or if I've had a jar of olives that has come from the supermarket, it's got really great flavors in that oil, I can maybe put chilies or garlic in it and make a chili and garlic oil and reuse that again. Other things I can let set. So if it's fats from like an air fryer or a barbecue, I can actually pour that into the jar and it will set hard, and then it's much easier to throw out. But it's a key thing not to put those in down the drain, because you can get something called a fatberg, where the fats and oils get set into like a solid mixed up with food and other things and paper towel, cloths and materials and wipes, and they can impact our entire urban water system. So different areas will actually be talking about those kinds of things when they find fatbergs, and it blocks up the whole sewage and stormwater systems. It can be quite disgusting. Uh, Excellent. We had another one over here. Eloise, do oil spills impact swimming and other activities? Yeah. If there was an oil spill, you wouldn't want to swim through it at all. Because think about it, the oil I'm using is vegetable oil. So it's not too bad. But if you think about a lot of the oil spills, it would be really heavy chemical oils and petrols. You would not want that on your skin. It could cause lots of reactions. Certainly in Sydney recently, they've been having these oil balls being washed up onto the shore, and they've been trying to look at what's in them, and they've been floating up to the beaches, and they've had to close the beaches because they're concerned that there's chemicals and oils and fats and petrols all kind of molded into these balls that float. And then eventually been washing up onto the shore. So lots of impacts there as well. Definitely not something that you would want to go swimming in that environment because it would get onto your skin and could absolutely cause skin reactions. Do coconuts break down? Yeah. So coconuts would break down in a couple of different ways, and we often will. I've often found the little bits of coconut fiber balls washed up on the shore. So as the rough part of the coconut rubs and wears down, those bits of sort of husk form little balls as well. But eventually that coconut would bang into other things, break down over time and break into smaller and smaller pieces. So yeah, especially when things are traveling long distances, but other times it can get from one island to another and actually land on the sand and put its roots down and grow a new coconut tree. So lots of things do travel by floating from one place to the other. And Ashley, I don't know how long it takes for a coconut to break down. It would definitely depend on the conditions, whether it was really rough and stormy, whether they were banging into each other. But a lot of things will float for quite some time out to sea. So that's a really tricky one to answer. Thank you everyone for joining me today, and thank you for your amazing questions that you've had here today as well. I look forward to seeing you again soon. I'll be sharing some information about these sessions for the activities that you can do at home, but keep an eye out. We have our next big event coming up in term 4 on Thursday, the 16th of October for Earth Science Week. So we'll have lots more information there. Oh, one last question. Dominic wants to know, can money be broken down? Very much depends on the money. In Australia, we have that really great plastic polymer money. It's actually waterproof, so it's pretty hard to break down. In other countries, they've got paper money that would break down really quickly over time. So it really depends on the type of money. In terms of coins, they would last, they're metal, they would last for quite a long time. So that's why they've even found in shipwrecks and things like that, money and coins from ancient Roman times and Egyptian times in the Mediterranean and places like that. So some things can last a long time. Oh, what about golds and diamonds, Ashley? Well, again, they last a really long time. Gold is pretty soft, so it can actually get a little bit damaged, but it doesn't get impacted by water. Diamonds as well, nothing is going to destroy them. So if you can find them, if they've been lost at sea, it would be finding buried treasure. So a couple of days ago was Talk Like a Pirate Day. So I can imagine the pirate maps to find money, gold and diamonds would be very exciting. Okay, thank you so much, everyone. I look forward to seeing you again soon. Bye, everyone. Riverfest is brought to you by Parramatta River Catchment Groups, Our Living River.